Hello, my name's Mark. I'm a partner engineer on the ceramic team. And today I wanted to talk through a simple demo app that I built that allows devs to pull transaction data against an address across two chains and then write that data to ceramic. And it's actually an adaptation of an open source Python tool that I did not build. So I've included a reference to the original project in the README of this repo. So I'll link to that repo in the video description, this one. I also included a API route that queries the passport humanity score. So you'll be able to obtain a humanity score for that same address. And the idea or the use case in this instance is if devs want an easy way to query and filter through transactions and make inferences based on cross-chain behavior. And maybe they also want a humanity qualifier to use as a means of creating sublists of highly engaged or loyal non-Sybil customers. So, like I said, I'll link to this in the video description, but first, just go ahead and clone this repo, and I have it open locally, so I'll go ahead and open it up. And we'll actually jump first to this call to get transactions. And you'll notice that what we're using here are Etherscan and Basescan. So we'll be using API routes to grab transaction history across both chains for an address input. And eventually, this method will return all transactions. And the original tool inputted that output into a CSV file that you could download. What we're going to be doing instead is writing it directly to ComposeDB. And in order to accommodate that data, what we've done is defined a transaction model. And we're also creating indexes on the subfield. So we'll be able to filter, query, and order based on everything that has a defined index. But this gives you an idea of what the anatomy of the transactions look like as they're coming through. So you'll have, of course, from is just going to be static. It's going to be the input address. And then to is the contract address that the transaction is made to. So we have a bunch of subfields here that are going to be highly useful for us as we observe the transaction history for a given input address. I'll also go back to the README and just point out that there's a few dependencies that we are going to be needing. So an Etherscan API key, same with the base API key, because we'll be using both of those APIs to pull transaction history, a ceramic private key. So I'll cover this now, actually. There's generally two types of applications that are built on ceramic, or these types of applications use predominantly two different design patterns when writing data to ceramic, one of which is user-owned data. So user authenticates themselves browser side, that creates a user session, and they write data to ceramic in the form of a delegated DID key that your application will use to write on their behalf. Whereas other applications, or another way of writing data to ceramic, is on behalf of the application itself. And typically that's done server-side using a static DID key that represents the identity of that application. So we're going to be using the latter for this demo, but it's very easy to switch this up and allow your browser-side users to own the data that they're going to be scraping. And I'll quickly call out where that sits. So we'll eventually be hitting this utility called save with key. And you can see how we're importing a static key, turning it into a DID key, setting that DID key as the authenticator, the authenticated DID on our ComposeDB endpoint, which is just our local host 7007, and then performing a mutation query with the input data. And then you'll also need to obtain a project ID from Wallet Connect. So I included some instructions there. And I do want to point out that when you do run npm run dev, you'll notice that it's hitting this run script, which lives here. And this is responsible for doing a whole bunch of things for us. So it's going to be generating admin credentials that our application will use to later deploy the models, the model that we just went over, the types, the transaction model. It'll also be setting up a GraphQL instance on port 5002, I think. Yep. And then finally spinning up our UI. So we'll be able to interact with our endpoint and see the data that we're scraping. So after you've went ahead and set up your environment variables, we can go ahead and of course, after running npm install, npm run dev. Awesome. So we'll open this up in our UI. Cool. And I included the ability to connect your wallet browser side and have that be the address you want to index transaction history against. I also included just a default address that you can use. So if you're not logged in, like I'm not right now, I can just use this default address. So we'll go ahead and do that. And you'll notice first that it's hitting our passport score or obtaining that. So just to point out where that lives, we have an API route called passport, and then this imports from a utility that is able to use our environment variables, our Gitcoin API key and score ID, which, by the way, I forgot to mention you have to set up in order to use this. And I've included those instructions in the README as well. And then goes through the sequence of events necessary to grab the proof of humanity score. So presumably you could use this to say, okay, if this address obtains a score above a certain threshold, we're going to consider them non-civil. So just to go back to the front end, I've also included a React hook just to render the transaction count once it comes in. So we know once it comes in, we're able to go over and start reading our data. And what I've done here is just spun up a GraphQL instance that's embedded within this page. You can just use this directly. And I've just included one very specific query that you could use. So let's say you want to see if that input address has interacted with the Uniswap universal router on mainnet, and also used Rhinofy bridge on base. We can go ahead and do that search, and we'll see that yes, we have one transaction for each of those constraints. And that's about it. So the possibilities here are kind of endless when it comes to the ability to really, really get specific in your filtering, querying, and ordering. You can do complex joins, or even add additional models into your composite to pull in other data that you might want to combine with on-chain history. So there you have it. And as always, reach out with any questions. Would love to hear from you. All right, bye.